All right, so let's just think about what this looks like as a graph first. How would I graph -6, -4 pi over 3? Well, the first thing I'm going to do is, let's think of it first as, what if it was just +6, and then we're going to graph negative, so we're going to graph this blue part first, and I'm going to go -4 pi over 3. Well, let's think of that. If I go negative, that's telling me to go clockwise, and then 4 pi over 3, every third is a pi over 3. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3s, and then this would be 4 pi over 3, but it's in the negative direction, so we're going clockwise. So this would be the location if we had a +6. Well, what does the negative do? What does the negative right here do to it? It makes the vector go in the opposite direction. So instead of being in quadrant 2, we're actually right here in quadrant 4. So this is kind of the right triangle that if I was going to graph this, let me move this so we don't get confused. This location would be the graph of the polar coordinate. Now, keep in mind we'd have all those circles around here, right? I just didn't draw all that in because it would have a radius of 6 circles out, and then we'd rotate it pi over 4. But what we do now is, now that we know the location, let's think about what we just have. I have my radius and I have theta. The radius is how long the hypotenuse is, and then your angle here is, well, actually this angle is pi over 3. This angle here is the reference angle, which is just a single pi over 3. So what I need to know from that is I got to be able to find the x value and the y value, which will be my rectangular coordinates. Now, you may have memorized that formula that we gave you. I'll write that down. I didn't memorize the formula. I memorized the fact that I have a right triangle, and I know the angle measure, and I know the radius, which means I can use regular SOHCAHTOA to find the angle measure. Now, you do have to be careful of what degree your calculator is in, because here we're dealing with radians. So that's something that if you were in degrees mode, you would probably get this question wrong, even if you did everything right. You got to be conscious of what mode you're in. But how would I find the x value? Well, let's think about it. What do I know? I have the radius, which is the hypotenuse, and I want to find x, which is the adjacent. So I could do cosine of the angle pi over 3 equals x over the radius. Now, what formula did we give you guys? We gave you the formula that x was equal to the length of the radius times the cosine of the angle. That's the formula we gave you, but where did it come from? It came from just SOHCAHTOA. So you don't have to memorize that formula just to get it. You can do regular with SOHCAHTOA, and now I'm going to do the unit circle. What is the cosine of pi over 3? All right, so if we think of it, if I had pi over 3 would be here. What is the cosine? Cosine is 1/2 square root of 3 over 2. Let's flip that around. So which one's the cosine? Here's cosine. I know that we get cosine is, and actually, because we're in quadrant, well, we'll deal with it in a second. When I simplify this, we get x equals, it says -3, but I have to be conscious because -3 would put me in this direction. But we're not at -3, we're actually at +3. So one of the ways we could have combated that is the radius really could just be always positive. But the other part is knowing where your graph is. So the first coordinate is 3. Now we have to do the same thing for the y coordinate. Now if you memorize that formula for y, you could just say y equals the radius times the sine of theta. That was the formula, but where does that come from, right? I don't like to just say, hey, let's memorize formulas. Where did it come from? The y value is right here. That is at the opposite of my reference angle. So opposite over hypotenuse tells me the sine of the angle is equal to the opposite, which was y, over the hypotenuse. Now watch what happens. If I times by -6 over to the side, I get y equals the sine of the angle, and we know what that angle is. So, however you do it, I like to just go back to SOHCAHTOA. Now we have to figure out what is the sine of pi over 3. We already know that. The sine of pi over 3 from the unit circle is 3 squared root of 2. Think of that as a fraction, -6 over 1. And I've got -6 divided by 2 is -3 square roots of 3. Yes, you could grab your calculator and get that answer. But there's my x and y coordinates that I need to officially write as an ordered pair. And then you should always check the sine value. Is that accurate? If x is positive, I move to the right. If y is negative, I move down, and that puts me right at the location where I want to be at. Okay. This is really a SOHCAHTOA problem in disguise. All right, let's look at what if I have the rectangular coordinates, and I gotta go forward. Maybe one of the things I assumed too much on the first problem was, remember, when we say we have rectangular, that's the xy. When we go to polar coordinates are what's the radius and what's the angle measure. So, I'm a visual learner. If I take this information and graph it, it doesn't have to be accurate. I'm going to go -3. So x is -3. Y is 11. And I need to find the radius and the angle measure. It's really just a trig problem. Right? So if you just memorize the formulas that we gave you, the formula we gave you was take the x squared plus the y squared, take the square root, that'll give you the radius. Well, where did that come from? Pythagorean theorem. A squared plus b squared equals c squared. So this is just a faster way of setting up your information. The only thing you have to be careful with is when you square your x, make sure you put parentheses around that. Hopefully you don't grab a calculator. You just do part of this in your head. Alright, so -3 squared is 9, 11 squared is 121. We get the square root of 130. Now I will bring up one thing that I saw on the quiz, and it could happen again, is the directions. I didn't give you these specific directions, but the directions always said round to the nearest tenth. right? It might even say nearest 100. If you didn't round accurately, you didn't get the points. Although I did go back through on the quiz and check to see if it was a rounding error you made. I gave you partial credit. I didn't just mark it all wrong. But if we say round to the nearest 10th, and I have, this is a decimal, then I'm going to just say 11.4. So there's my radius for the polar coordinate.
You did the same thing for the
Yes. Yep. You could have, and maybe I should have, you could have done, the test will be more specific too. It'll tell you to round, mostly because we can't enter this into Schoology. So, yeah, if you wrote 3, negative 5.2, then you would have rounded accurately to the nearest 10. Okay, so that's the radius. That's the first part of the coordinate. Now I have to find theta. Well, finding an angle is undoing a trig function. So let's look at the fact that if this is theta right here, and I have the opposite, and I have the adjacent, now we gave you a formula for theta, but you don't need it. You know trig. So watch what happens. If I set this up, the tangent of theta is equal to the opposite over the adjacent. Well, the formula that we gave you just did this step for you. It moved the tangent over, and the formula that we gave you was the tangent of the y over x. So it's the same thing. And then here's the important piece. You get to, now we are in radian mode here. If they said degrees, so what if I told you that this had to be degrees? Right? Then I have to change my mode. And so I'd go to mode, my calculator, change it to degrees. And then I would do the inverse. And you have to be really careful too. Is that my answer? Well, let's check. If I was to graph negative 74, that tells me to go this way, I would end right about here. That's not the angle measure I need. Right? I need the angle measure that goes from 0 to the radius, the initial side to the terminal side. So I do know that this answer right here is the size of that reference angle. What I need to do is I need to take 180 and subtract the reference angle of 74.7, because that'll give me the angle measure that I need. And I think that's 105.3. And then if you're not confident in your answer, the best part about these answers is when you write your polar coordinates, if you were to actually graph that, you would have to go out 11.4. Let me see if I can, I'm not sure if it's going to work the way I want it to. But I'd have to have a radius of 11.4, and I'd have to rotate this 105.3 degrees. And is that right where my picture is? That's the coordinate, the polar coordinate that is matches with the point negative 311. All right, last one, find the magnitude and the direction. So when we say magnitude, remember our notation? Sometimes it was 1 bar, sometimes it was 2. But they give us our component form of the vector. if you want to think graphically, let's think about what this means. If this vector was positioned at the origin, I would go over 4, up 7. So over 4, up 7. That's a very poor sketch, but it doesn't have to be super detailed. There's the vector. Well, the magnitude is how long is it? It's the same thing as the radius. So if I want to find the magnitude, it's taking and doing the Pythagorean theorem. If you know your x and your y, then over 4 up 7. 4 squared plus 7 squared. And that's 55, I believe. And then if the directions say, now if this was a Schoology test, we couldn't type in the square root of 65. So it might say round to the nearest 10th. Or it might say round to the nearest 100th. If it's the nearest 10th, you get the magnitude of 8.1. And then it says find the direction. Well, what is the direction? That's theta. Find the measure of that angle. We have a right triangle. It's the exact same work we just did. I have an angle, and I know the opposite side, and I know the adjacent side. So to find theta, it's the inverse of the opposite over adjacent. Inverse of tangents. And then again, I didn't think about this when I was doing it. Let's do this in degrees. So my calculator's in degrees mode. And I'll round that to the nearest. There's my magnitude, there's my direction. Notice how all three problems, if you had a graph, it was really just either regular SOHCAHTOA, Pythagorean theorem, or inverse SOHCAHTOA. Okay, so what do we got today? I want to show you Schoology, just so you guys are all aware of where everything is. Okay, well, first off, so last week, and I think we really have to do a much better job of this. I don't know if you guys are viewing Friday as optional. Some of you talk to me, and that's fine, but as of right now, 9 out of the 29 kids in class took the quiz on Friday. It was right here, it's in Schoology, we talked about it in class, it was written in the agenda for week 6, and you just didn't do it, and then you got to submit your work as well. So that has to be on some of your plate. That was a 20-point quiz. You can do corrections on that. I'll talk about that at the end of the hour here in maybe 5 minutes once we break out into work time. But if that quiz, you should now be able to see your results if you took it. And if it didn't go your way, then you can do corrections for full credit. And I'll explain that in a second. But what are we doing today in class? Let's go and read the week just so you guys are aware. Here's the week agenda. So in class, we're going to do a Chapter 6 review. And there's 19 questions, I think. Is that right? 19 questions. However, some of them are very quick. Graph the rectangular point, graph the polar coordinate point. So it's 19 sounds like a lot, but it's not as much as you think. So we're going to do that in class. Then you have the option of doing quiz corrections. This is optional. You would do that on a separate sheet of paper and correct any questions that were technically wrong on the original quiz. And then you have to email me that work because there isn't a spot in Schoology to submit it. So just say, Strub, here's my 6-2 corrections. I'll look over them. If they look good, then you'll get full points back on that quiz. All right? Some of you still have to take that, though. The homework for tonight, then, is to correct any of the problems that you got wrong on today's Chapter 6 review and submit an image of your to the assignment below. That's in the Tuesday folder. If you scored 100%, then all you have to do is type a comment. I got them all right, Strub. You can check, and then I'll go on and check in there. So that's today. Thursday, we are doing the test in class, starting at 11:03. And then you're going to submit all your work on a separate sheet of paper, just like we've done for every test and quiz, basically this year. And then Friday is a day to get caught up and work on either test or quiz corrections or anything missing. Remember, we only have about 4 weeks left until the gradebook closes. So, here's what you're going to do. When you go to Tuesday, same agenda. The Chapter 6 review is right here. And then this is where you submit your corrections later on. So I set this up when I click on it. Here, I'll do a preview. It's a 5-point assignment. Okay? But really, the reason why we're doing this is to prepare you for the test. If you do well on this, this test is going to be a breeze on Thursday. So when you click on it, some of them are drag and drops. I'm not saying these are the right answers. I'm just grabbing them. Okay? And then go to the next one. Some of them are short answers. If you do not round accurately, then you're going to get it wrong. And you'll notice that when you go back to correct it. And that's one of the things we also test is on an ACT, if you don't round correct, it's wrong. So even though you're close, you're not going to get credit until you get it accurate. I believe, and I don't think this will be the case when you guys view it. It could be my window, but notice this is the rectangular coordinate. So here's the X part and here's the Y part. It should look better. I don't know why it's not. Anyways, you're going to go through, and some of the questions are a little longer. Some are really quick multiple choice. So that's what we got. And I will tell you, I was going to tell you what's going to be on the test, too, just so you know. So that way you know on Thursday, the test is 50 summative points. We will take it in class on the 29th. It's due at 12:10 p.m. I should say in the afternoon. Because what I'm noticing is some of you on Zoom or some of you at home are deciding not to take the test, and I don't know what you're doing during this hour, but I'm going to basically say if you don't have it in at this time, I'm going to email home, and I'll just say, your son or daughter did not do what they were expected to in class. Therefore, they are missing this assignment, and I don't know. I have to find a way for you guys to actually do the work when you're supposed to. Okay, and then submit your worked out solutions. That's worth 5 extra points summative. That's like 3 points. You have to submit your work when you're done because I use that work and go back to correct your test. If you don't turn in work, then you get it 100% wrong. I can't give you any partial credit. All right? It's 14 questions long. Difference of some of them are multiple choice, fill in the blank, or drag and drop. You must round accurately, otherwise you won't get it right. And what are the topics we've covered? Some of these we just did. Convert from rectangular to polar. Convert from polar to rectangular. Find the component form of a vector. Vector addition and multiplication. Find the magnitude and direction of a vector. We did that in a warm-up. Plotting polar points, writing and solving parametric equations, and eliminating parameters. If you did the 2 quizzes this unit, you experienced every single one of these problems. All right, so this is what we got. Right now in class, you're going to start the 19 questions on the review. If you finish them, you could start correcting them. In the afternoon session, I am going to release the answers to these 19 questions with my worked out solutions. I will post them in the answer portion of Schoology. So just so you guys are aware, we haven't used this a lot because a lot of stuff we did in Delta Math, but in our pre-calculus slide, there's the homework, and I will post them right here. It'll say Chapter 6 review answers. That's how you're going to go through and correct to make sure you know exactly what you're doing. Okay? And then if you finish all that, you should either take the quiz that you missed or do the corrections. So right now, go ahead and open up the Chapter 6 review in Schoology, and we're going to work through that. I am going to ask that everybody stays on Zoom until the end of the hour, because if you're not working on it, then I can message you and say, hey, how come you're not doing it? So nobody leaves Zoom. All right. Yes. I do. You actually have one on your laptop. Is that a school laptop? If you go to the bottom bar, the apps, type in EIP. Well, that should follow all of them. Well, you get your stuff there. Here it is. I'd rather have you use this, because this review is just an assignment, and it'll tell you what you know, and most likely, when you get to those parts for that, they'll teach you that that's what I don't know, which is fun, right? Because you'll get in more software. But that way you get this done, and then you have an idea of what you know, and then you can